Will artificial intelligence improve the computer technologies? That's what I'd like to ask in this video. I don't know what artificial intelligence is. It seems like every other program that comes out, oh, we are able to add two numbers, so it must be artificial and it must be intelligent. Maybe it's analyzing languages. We've done that for about 80 years. Find the cat in the picture? Maybe. I mean, these algorithms are not that big, not that complex. But I think we first need to see if they're even on the right track. So I'm not going to worry about what artificial intelligence is, but I'm going to ask the question, are they going to be able to fix what's wrong with our computer systems? And so what we need to do is look at what the problems are. Some of them, I can't look at them all. About 12 years ago, I was asked by eBay to interview for a position to run 200 men in Shanghai to rewrite the foundation of their computer system. I didn't get the job. They wanted a manager, my assumption, but I don't know. I never got talking about technologies anyway. Anyway, they wanted to rewrite their foundation. And I said, I'll take a look at it. They had done 3 previous versions of their computer system. Now they wanted something that actually worked. I mean, I think we all go through that. I don't know of any system out there that is actually working. Anyway, I didn't get the job, but it started me thinking. Okay, this was about 11 or 12 years ago. And I thought, well, could I actually write them a better system? And I thought, yes, I can write them a better system, which is can have conformity between a lot of dissimilar systems, have everything consistent, remove all possible human involvement in the production at the user end, that are the sellers, and then the internals of eBay, and have that controllable from one system. Yeah, I could write something like that. And they'd tried this 3 times before. And I thought for 2 weeks, I thought, can I really do this? I said, no, I don't think I can. I can write them a better system, but I can't write them the system they need. And so I said, okay, not using our current technology. Not using the same technology that they used on their 3 previous attempts. Web interface, basically, but it's still just software. To me, I don't care what you're writing, it's software is software. Whether you're running a device driver or a hardware operating system or CPU instruction sets, it's software. They're instructions that the computer is going to perform. I said, well, what doesn't work in our computer systems? What is the problem? Well, the problem is we have independent applications. None of our applications talk to each other. They're all written from base foundation instructions. And anytime I write an application, I start brand new, have to figure out just about everything there is, and then I have to reinvent the wheel on every subsystem. That doesn't work. We've tried billions of them. We have billions of applications. None of them really work. Client-server technology. Well, basically this is when any 2 applications try to communicate. We have system A, let's say a server type of thing, and then the client, which is B. So B is trying to send instructions to A to tell it to do something, and vice versa. The reason is that no system A doesn't know what B is really needing. It can assume. So once you assume purpose, you design that purpose. I think he's going to want to do this. I think he's going to do that. So we have web servers, we have cloud technologies that says, oh, we'll send us the instructions and we'll perform them for you. Not effectively, not to the point where we can reduce human involvement in the setup, procedures, maintenance, and management of these systems. Okay. Our keyboards. The other failure in our system is we don't have enough characters representations to do anything. And our font technology. This is locked up in copyright, so we really don't get access to the fonts, and they're so one-dimensional that they're worthless for any type of editing technology that you'd want to create, at least at my scale. Sure, you can write the things we have right now. We have 15 billion editors, all of them different, all of them do the same thing. Our font technology really doesn't support what needs to be accomplished. Our CPU instruction set doesn't work. Our CPUs, the way our hardware is built, doesn't really work. It's an application, hardwired, but it's still an application. It performs an action. It does add, subtract, multiply, divide, compare, jumps, and moves. And that's basically it. And then all of our software is based upon that. Now, if that's the extent of our technology, which it is, then every application can only use those instructions. Our data sharing. We have no data sharing at all because of our applications are being independent. One application only works on one data structure. And so there is no sharing. We cannot write another application to access that. Technically, we could. Practically, we don't. Basically, because they lock it out, and if like AutoCAD or PDFs and things, they will encrypt certain parts of it if it gets too wide known that here's a format that people really want access to. They will encrypt it or obfuscate it or do something to keep the user from his own information. And so that's our technology. So is artificial intelligence going to overcome these restrictions that have been built by the monopolies to restrict people from doing exactly what we need to accomplish? No. So hardware access, which is again in a sense two applications trying to talk to each other. And right now we as developers don't really have direct access to it. I won't bore you with technical details of why this is, but that's our problem. We have to go through device drivers and what they're calling device drivers aren't really device drivers. They're still all mostly using RS-232 or some ISP or some protocol that some other application, some other device driver. Depends on the system you're on what they call a device driver. Okay, our security. Okay, this is another issue. This is built by a third party again to perform actions that we want as for our applications, and we can't control that. Therefore, it's again a client server, if you wish, technology, which we know doesn't work, or I know it doesn't work. Maybe nobody else in the world knows that, but I do. I have 50 years experience, and this is all I fight. Our compilers. Our compilers are not compilers. They're glorified assemblers. That's all they do. They don't do anything else. They all have different conventions. I'm writing my own compiler, which is Jane, which is my system. Anyway, I won't bother you with that technology, but our current compilers only do hardware instructions, so it only does a very limited hardware instruction set. Since there's so many versions of our CPU hardware instruction set that the compiler cannot determine which instructions actually exist on that CPU all the time. It's easier to go to the lowest common denominator, work in, add, subtract, multiply, and divide, instead of trying to use some of these special case multi-register instructions, like the array type of instructions and things that have been optimized for a particular purpose. But the compilers themselves don't even get there or use optimized hardware instructions. Our file system. We have files and folders, and that's been our technology from day one. And that doesn't work because we have no idea what's in them. And they're just blobs of bits that we have no concept of what they do or perform or a purpose. Versions. Versions means that the product is never finished, apparently, because we're bombarded with version after version of every product out there. I had a quote in my last newsletter. Software is needed because it is designed to be needed. Versions are done because we're forcing the client to upgrade their systems. Nobody wants an upgrade. Nobody. Which means our products are never finished. They're not finished on purpose. And then we have a name value technology. I'm naming things that don't work. Okay. Our name value technology, methodology, if you will. Okay, we have assembler, and this is where it started. We had an assembler, and at address 1000, we put the value 10 for the guy's age, or whatever purpose it is, which was hard-coded in the source code. And we said, well, we don't really know what's in 1000. Let's put a name on it so we can remember. And so we put a name on it. But we don't know what the name means. I mean, it's a name. Do we really know the value and the purpose of the name? No, and we shouldn't. But people try. I mean, we've tried, like I said, billions of applications with billions of names. I go in one, and it's like, I have no idea what those words mean. And I don't know what the value of 10 is. I don't know what the purpose is. What is 10? And what is X? I don't know. I have to go look at the source code. I don't have the source code. So I have no concept of this technology, this methodology of name value. And this is our high level, highly useless technology. It doesn't work. No, we put scope in it, and that's supposed to help. No, it doesn't. And then we have hard-coded logic. So all of this is hard-coded so that we have, oh, well, we put X in there, we put 10 in there. Oh, well, I'll say that's the index into X. We're into 8, okay. So we have X as a value of 10, and I'll say, so I'll hard-code it, and I'll just use X as an index into A. So A is a list or something, I assume. I'll have to go look that up, see what A really is. 10 is an index, but I don't know what the index is of. Now, does it start at 1, do 0, or some other relative offset? So this is all human-based, hard-coded logic, which is really useless, unreadable, ununderstandable. Is artificial intelligence going to fix these trivial things and then move forward? And so we'll look at what we want. So what do we want? Okay. Now that we know what doesn't work, or some of the things, there's about 10 million other things I could gripe about that don't work. Theoretically, everything works. Practically, none of it really does. Can't be modified. Can't be looked at, understood. We have to run them to see if they even work. We don't know. This should be like a book. We should be able to read it and have confidence in our reading ability to tell us exactly what's going to happen and why it's going to happen and what are the limitations and the faults within our logic. Not run it and then hope to God it's going to work. Anyway, so what do we really want? If I had to do any system out there, any application, first thing I want is an infinitely large application. Okay. When I looked at eBay, I thought that's kind of what we need, really. I mean, we want one application, no boundaries on data. So I looked at the internet, and the internet is literally an infinitely large document. You put the A tag, you get to it, fine, okay, no matter where it's at. And so that's kind of starting point. And I said, well, okay, could I do the same thing with an application? Well, I said no, because no two applications work. I cannot communicate one application to another application exactly what needs to be done because they're both doing redundant work. This one has to understand and tell, and this one has to somehow understand and perform. I've yet to see any program, other than a trivial one, turn on the light and the light comes on. Yes, I can understand that. But above that, no. So I said, infinitely large application. I said, okay, what will that take? And I said, okay, it's got to be one application. No boundaries at all between anything. That way, the one application has full control of everything. Okay, and you say, well, what about client server? Okay, well, I won't get into that, but in essence, we take part of our program, send it over to the other one, let it run on that machine, and so we're actually doing the instructions, but in a more convenient way than this is all done by the compiler. This is all done within the instruction set, so we're not coding anything. We just say A equals B times C, and they're all on 3 different machines. We let the computer do it. We don't have to do anything. So this can be spread across billions of machines and do all the stupid little things that we need to be able to do. You know, we're getting to be global companies, and yet we can't really communicate. Next, we need a visual representation of all knowledge in all forms for all technologies. What does this mean is that we need math expressions as we write on paper. We need an editor to be able to do that. Same way for every other technology. With the symbols, literally, that we're using. And have the user have the ability to create his own symbol. So we throw away the font technology we have now and go to one that's both static and dynamic and perfectly preserved no matter where that document ends up. Space is cheap. We're moving things around now. And so we should be able to encode that into our documents. So we move intelligence into the document, not in the source code. We do not need hard-coded data structures and logic. I mean, because you got lookup tables for specialized processes for temperature. It's not a lookup table. It's a calculation. So if you come up with a new temperature or something, you need to be able to convert Kelvin to Fahrenheit. Send that code with your application, with your document. Anybody else will know exactly how you calculate it, and they can validate it, and the system can validate it. Anyway, there's a whole lot of things we don't even do in our software development that we could do automatically. But we really need visual representation of everything we write on paper so that physics and mathematics and chemistry and music and dance and every other technology out there can utilize our screen with the symbology that's meaningful to them. Every company may have. I was in mapping for many, many years, and we used a lot of paper maps, and the size of the symbols. I know a company would spend 6-8 months. Well, it should be 3/8 of an inch, or should it be a 1/4 inch symbology for a street light, or just all the symbols. And that's how critical symbology is, because maps have very unique symbology. So does electric design. So if you do electric design, you need all those symbols available to be modified by the user so they can put in color and styles and their own symbology. They may have their own they may be doing plant design, and you don't realize that this is reality that we're trying to represent, and yet we're trying to represent it with ASCII characters. Stupid little font technologies that don't work. We need absolute control of the hardware we purchase. So the user says, look, if I can't tell my camera to take my picture through my software, I don't want other people's software on my hardware. Literally. It's my hardware, it's my knowledge, It's my information. I don't want it to go anywhere, and I want to trust 100%. And is artificial going to do this? Artificial intelligence going to do this? I've never heard it. So we need absolute security. Like I said, I want to know what's going on. We don't have security, okay? We only need one of anything. So all of our logic, in our billions of applications we probably have 10 billion variations of the same thing. Add two numbers. There's a billion ways to represent that. Most of them are done at the hardware, but there are variations of that from machine to machine. We need where it's a technology so that it works everywhere, and absolutely. So we need one of everything. We need one editor. So instead of 15 billion variations of an editor, we need one. We need one compiler, one interface that we either talk to, we put in scripts, or we put in forms, whatever representation of an action request that we can do. If it's a handshake or hand signal, or it doesn't matter. We need one interface into that. We need one language so that everybody understands it. If we can get there, we have yet to even start getting there, but artificial intelligence is trying to come up with better languages. But we first have to do the fundamentals. Our character set. If we don't have a character of a resistor, two resistors. Why have symbols and characters when they're both the same from the technical side? Practical side, it's a little easier to understand for the human, and that's why we do it. But from the technical side, we really need to be doing what is best for the computer, not for the human, because we're trying to reduce the amount of work for the human. Sure, we can separate them logically, sure. But we don't need, the computer shouldn't care. I'm drawing symbol here, period. Okay, we need base knowledge. We need fundamental base knowledge in the compiler, in the system, so that it knows Gone with the Wind. It knows what a resistor is. It knows what types of ducks and the types of frogs. It needs to know all the boys' names, all the girls' names, all the names that are boys and girls' names, and all the variations of reality. We have all the space in the world. It doesn't mean that we have to immediately do this. I'm saying we need to build a system that has a place for this before we even start. Before we first get our first bit of information, the whole system has to be designed so that it's possible to do, not that it has to be done. And it has to be modifiable. And we need a number technology. We don't have a number technology. We have a number application. About variabling. Why can't we have variabling? Why can't we use a different base? Base 10. First computers were base 10. Base 2. Base 3.5. Who cares what the base is? These are, again, it's purpose. Software should not have a purpose. It should be a technology that handles all purpose for a particular term or data structure. So if I'm dealing with numbers, the order of the numbers. So if I want to do security on my system, I could tell the system, look, change the orders of all my numbers. Instead of going from 0 to 32, go from 5, 8, 7. Change the order of the bits. We can do this. And then you talk about security. Anyway, there's a whole range of security issues. And our hardware design, we need to get that to be constant. It doesn't have to be implemented the same, but we have to have an interface that we can ask the system that literally, right now it's hard-coded in documentation. We got to get rid of documentation. These are things we really need. We need forward and backward compatible logic and information structures. Means that if I make an application today and create a data structure, we have to have the ability to change that data structure and the logic at any time from now till eternity. You can do this. Instead of putting these variable things in our logic, we put it in our data structure. GPS, we've had 3 versions. Just modified the logic to begin with, we would have 1 version. We just changed the number. It's simple. I'm sorry, but this just irritates me to no end. We're not doing software work for the dang. And then finally, is AI going to give us trust and confidence in our software? No, I don't believe it. It could. Well, it can't. Not without changing the basic foundation of our technology, of computers. I just see that every line of code, I have 50 years experience almost. Every line of code I type in, I have no idea if it's actually going to do what I expect it to do. Because of 90% of our software is actually invisible. They're in the operating system. The operating system took it over as being a responsibility. Actually, it's a lock into their operating system. If we didn't have that, it's really not anybody's responsibility. And so, but they took it over. Oh, we will draw on the screen for you. We will do device drivers for you. We will do basically anything that will keep you from being able to take advantage of your own hardware. I know this sounds strange, but I don't know what AI is going to perform. Is it going to fix the problems? I have no idea. We'll see a lot of applications say, oh yeah, look at this. We found the cat in the picture. Well, yeah. Anyway, well, thank you for your time. Hopefully you understand where I'm trying to go. My system is to accomplish what we want. And the only way I can do that is to get rid of everything we have now. Because mine is just one application. I can't use anybody. I can still run them, and if that helps you, great. I'm not destroying anything. I'm just building a system that can be done that will in maybe 100 years we'll get to the point where yes, we won't need people. Every person on the planet will have their own environment, their own need for the computer to be exactly what they need. So if you want to buy a car, you put your own software on it, and if you don't like automatic lights, or you want them on all the time, or whatever it is, you just qualify to the system that you want, which is really all we're trying to accomplish. We know what the logic is. There is nothing that we haven't done. We just need to be able to qualify for the user so that he can simply qualify each and every application that he runs without any borders, without any worry about security, not a thought to sharing it with anybody on the planet. Oh, I have this map and these are my notes, and and I send him one document, not 15,000 of them. He can split them up if he wants or whatever, and be able to use it on his system just like it was on my system without having to worry about software. Because software doesn't cost anything. There is no labor cost. Once it's done, there's no cost of the labor. There's no material cost at all in any software. There's no cost in transportation. Once it's done, and we only need to do it once, period, for everybody on the planet. And if I can do it by myself, literally, I could write every one of these things. Every editor, I'm doing the compiler, I'll be doing the editor. Thank you. Good day.